Hi, welcome to Sunil Maths tutorial. In this video, we'll learn about interior point and open set and its properties. Let us see the definition of interior point. Let capital A be an aggregate. Aggregate means it is the subset of real numbers. Aggregate means it is the subset of real numbers. An element capital A is an aggregate. An element P belongs to capital A. An element P belongs to capital A is called interior point of capital A. An element P belongs to capital A is called interior point of capital A if there exists a neighborhood of the point P. There exists a neighborhood of the point P which is entirely contained in A, which is entirely lies in A, which is entirely lies in A. So a point P belongs to capital A is called an interior point of the set capital A if there exists a neighborhood of that point P which is entirely lies in capital A. That is P is interior point of A implies and implied by there exists epsilon greater than 0 such that n epsilon of P is subset are equivalent to A. This n epsilon of P means epsilon neighborhood of the point P. Epsilon neighborhood of the point P. Right. Let us see one more point. The set of all interior points, of a aggregate capital A is called interior of capital A. If you write all the interior points of a set, then that set is known as interior of the set and it is denoted by A power 0 or int of A, but read as interior of A. You can written it as int of A, but read as interior of A. It is simply denoted by A power 0. It is simply denoted by A power 0, which represents interior of A, Let us see. Interior of real numbers is real numbers. Interior of real numbers is real numbers. Interior of rational numbers is empty set. Interior of integers, empty set. Interior of integers, empty set. One of the very important points to remember. What is the interior of the set of real numbers? Capital R. What is the set of interior of the set of rational numbers? Empty set. Now let us see the definition of open set. An aggregate capital A is said to be an open set. An aggregate capital A is said to be an open set if every element of capital A is an interior point of A. Every element of capital A is an interior point of A, then we say that the set is an open set. So a set is called open set if every element which is lies in the set must be an interior point. Let us see. That is A is open implies and implied by interior of A is equals to A. A power 0 represents interior of A, the set of all interior points of A. So A is open implies and implied by A power 0 is equals to A. Interior of A is equals to A. In other words, A is open implies and implied by capital A is a neighborhood of each and every point of A. Again, right definition. Any set is said to be open set if and only if it is the neighborhood of every point of A. It is the neighborhood of every point of A. The best examples for open sets are pi and set of real numbers. Empty set is an open set. The set of real numbers is also an open set. Natural numbers is not open. Integers not open. Rational numbers not open. But real numbers are open set. And let us see some important properties of open sets. The first one, the union of two open sets is again an open set. The union of two open sets is again an open set. Suppose A, B are open sets, implies as their union, A union B is also open set. The union of arbitrary family of open sets is open. The union of arbitrary family of open sets is also open. Let us see one more property. Every open interval is an open set, but open set need not be an interval. Remember that. One of the very important property. Every open interval every open interval is an open set, but open set need not be an open interval. Let us see next property. Every open set is a union of open intervals. Every open set can be written as union of open intervals. The intersection of two open sets is again an open set. The intersection of two open sets is again open set. Intersection of a finite number of open sets is again open. The intersection of a finite number of open sets is again open. Yes, let us see the next property, and which is important. The intersection of infinite number of open sets need not be open set. The intersection of infinite number of open sets need not be open set. So remember that these are the properties of open sets. In some another video, we prove some properties of open sets.